All right, hi, Algebra 2. This is Unit 3. We're going to go ahead and start the triangle unit. So right triangles. All this stuff obviously should be a little bit of review from the Algebra 2 course if you got to the trig. If not, this should be review from geometry. So almost, I think everything that we do in this unit is from geometry trig that you probably learned. All right, so let's go ahead and start some review problems first. So with radicals, if we are simplifying, whether we're multiplying or dividing or squaring, we want to make sure that we understand how to simplify that because these kind of problems kind of come up when we're solving triangles. All right, so if we're multiplying two radicals together, we want to go ahead and remember that we can multiply the outside numbers together and then the inside numbers together. All right, so outside stays with outside, inside stays with inside. And then from there, we can go ahead and simplify our radicals like we did before. All right, so on number one, there's a 1 in front of that radical 5, and there's a 1 in front of the radical 10. And again, if you just multiplied the 1 times the 1, you're just going to stay with 1 on the outside. But the 5 and the 10 we can multiply together because they're both inside. And so if we multiply that, that's 50, square root of 50. All right, so then we want to go ahead and simplify square root of 50, and we're going to keep our answers in the simplest radical form, and that's because of the directions tell us to do that. And so we could break this down into 10 and 5, and then 10 can break down to 5 and 2. And so you should simplify this down to 5 radical 2. 5 radical 2. All right, again, you could simplify square root of 50 if you see a perfect square. Okay, perfect square would be 25 times 2, and then the square root of 25 is 5, comes on the outside, the 2 stays on the inside. All right, so number 2, if we're dividing and we have a radical on the bottom, we want to go ahead and get rid of the radical on the bottom. It's called rationalizing the denominator. And so we can multiply top and bottom by the square root of 7. All right, top and bottom. And so multiplying across, because we're multiplying two fractions together. The 3 is on the outside, so it's going to multiply to the 1 that's in front of the radical 7. And that's just going to stay 3 radical 7 on top. Then on the bottom, we can multiply the 7 and the 7 together. That's 49. We get square root of 49, multiplying those together. But square root of 49 is perfect, and that's 7. Right? Square root of 49 is exactly 7. And if we could simplify, our fraction, the 3 and the 7, because they're both outside radicals. If we could simplify that, you want to simplify it. But in this case, you're not going to be able to. All right, and then number 3 squared of 9, and that whole quantity is being squared. And so you want to remember anytime we're squaring something, it really just means multiply by itself. All right, so square root of 9 times square root of 9, and that's going to be square root of 81, and that simplifies down to 9. All right, and again, I think we did this in with radicals. Unit 2. When you're squaring a square root, they kind of cancel each other out because they're inverse operations of each other. And then you can see whatever's underneath is the answer, 9. All right, so let's go ahead and continue on with our right triangles. So triangles have one right angle. Okay, we're looking at right triangles. There's other kinds of triangles, scalene, isosceles. Okay, there's obtuse triangles, there's acute triangles, all these different names. All right, so acute just means that you're going to have all the angles are less than 90. Obtuse, you're going to have one angle that's bigger than 90. And then right, you have one that's exactly 90. All right, so so triangles have one right triangle. The right triangles that we're looking at, they have two sides called bases, okay, and one side called the hypotenuse. So the hypotenuse is always going to be the side opposite the 90 degrees, okay, opposite the 90. That's our hypotenuse. This is always going to be the longest side, all right, and so we call this, this is the opposite, all right. So once you find an angle, there's 3 angles in the triangle, and you can always find its opposite side, right? And then we have 2 bases. So the hypotenuse is the side opposite the 90. That's the longest side. And then the other 2 sides or legs of the triangle are called bases. Okay. Yeah. So since they're both bases, it doesn't matter which one you call, a base. All right. So then we have Pythagorean theorem in right triangles. A squared plus b squared equals c squared. All right. And so The c squared is always the side that's opposite the 90 degrees, which is the hypotenuse. And again, we want to understand our opposite sides, right? And so when we label a triangle, the vertices, we use capital letters, okay? And then the sides, we can use a lowercase letter for its opposite side. So for opposite side of A, we could call this little a right here. So angle A gives us opposite side A, which is also side CB or BC. And then B, angle B has an opposite side. All right, that's lowercase b, or we could say it's also side AC or CA. And then opposite angle C, and that's our hypotenuse, C, and it's also side AB. So you can see that when you take the two bases, a squared plus b squared, that's going to equal the hypotenuse, which is c squared. All right, so then a Pythagorean triple consists of three numbers that satisfy the Pythagorean theorem. So if we were to take our three sides, and sometimes they give them to you in order from smallest to biggest, but they don't always do that. And all you really have to do is find the biggest number out of the three, and that has to be the c in the a squared plus b squared equals c squared. All right, and so we can verify that we have a right triangle by seeing that these are Pythagorean triples. All right, so if we did 3 squared plus 4 squared, that should equal 5 squared. All right, and we can verify it. And 9 plus 16 is 25, and so then 25 equals 25. So the left side equals the right side. B, again, we could check to see. Remember, 13 has to be the C, side C. So 5 squared plus 12 squared. And we're checking to see, is that equal 13 squared? All right, so that's 25 plus 144. And 13 squared, it's going to be 169. And then if you did 25 plus 144, that does equal 169. So 5, 12, 13 is also what's called the Pythagorean triple. 3, 4, 5 is the most popular one, but 5, 12, 13 is also another one. And then 8, 15, 17. Again, we can do the same thing and verify it. All right, so then 8 squared is 64. 15 squared, 225. And then 17 squared, 289. And then if we add 64 and 225, it looks like it's going to equal 289. All right, so then we have a question. Do the numbers 16, 10, and 12 form a Pythagorean triple? All right, so show your work. All right, so again, the biggest number has to be the C. And the other two, it doesn't matter which one's A and B. All right, so we can verify 10 squared plus 12 squared. Does that equal 16 squared? All right, so if it does, then it's a Pythagorean triple. All right, so 10 squared is 100 plus 12 squared, 144. And then 16 squared, I believe it's 256. All right, if we add 100 and 144 together, that's 244. And we are comparing that to 256. Since they're not equal, then it doesn't form a Pythagorean triple. All right, and the sides that make up a triangle 16, 10, and 12, with those sides would not be a right triangle. If you remember, since 244 is smaller than 256, this would be an acute right triangle because 244 is smaller than 256. Actually, we would look at it as we do the opposite. So if you want to compare, you would do c squared, and you're comparing it to a squared plus b squared. You have to do the reverse. All right, so 256, since it's bigger than 244, this would be an obtuse triangle. Obtuse. So not right. All right, so let's keep going. So 1 through 3, it says find the value of each variable. Leave the answer in simplest radical form. So we're going to use our Pythagorean triple. or Pythagorean theorem, sorry, because we have two sides of a right triangle. And so again, just make sure the side that's opposite to 90 is your C. All right, so solving this, we have x squared plus 7 squared equals 10 squared. And so x squared plus 49 equals 100. Subtract the 49. X squared equals 51. Square root it. All right, and we would normally do plus or minus. Remember, anytime you square root both sides of an equation, don't forget plus or minus. But because we're talking about the side length of a triangle, the side can't be negative, so we would only keep the positive. And then square root of 51, we would check to see if we could simplify that. It doesn't, and so x would equal the square root of 51. All right, number 2, let's see, 16 is opposite the 90, so that's our C. All right, so y squared plus 12 squared is equal to 16 squared. All right, so let's subtract 144 over on both sides. All right, so 112, square root it. All right, so then we want to check, could we simplify this? I know 2 goes into 112, so we can break this down. All right, so it's 2 times 56, and then 2 times 28, 2 times 14, 2 times 7. All right, and so remember, we're doing square roots, so we need to find pairs. All right, so here's a pair of 2's, and then there's another pair of 2's. All right, so we'll take each of those 2's out, multiply them together, it's going to get us 4. So that's 4 radical 7. Nothing pairs up to the 7. All right, and then number 3, z is our hypotenuse, so that's our C value. All right, so 8 squared plus 14 squared equals z squared. So 64 plus 196 equals z squared. Okay, we'll add 196 to 64. It's 260. Square root both sides. All right, now we've got to simplify that 260. All right, so we know 260 can break down to 2 times 130. 2 is 1, and let's see, 130 is 2 times 65. 65 is 5 and 13. All right, and so we do have a pair of 2's right here. So we'll pull a 2 out. And then the 5 and the 13 just get multiplied back together. All right, so this will simplify down to 2 radical 5 times 13 is 65. All right, so now we're going to look at some special right triangles. So there's 2 special right triangles, and we can use shortcuts instead of the Pythagorean theorem. So one of them is the 45, 45, 90, and then the other one is the 30, 60, 90. All right, so the 45, 45, 90 has 2 legs, and they're exactly the same because we have 2 45-degree angles and then 90. And so that means the 2 legs, or the 2 base sides, are going to be equal. And then the hypotenuse, and that's going to be whatever the leg is times radical 2. All right, so we can use this little ratio. U and U, that's the 2 legs, and then the hypotenuse is always whatever U is times radical 2. All right, so you can kind of see in this example, we have 2 legs that are both 10, so we know that we have a 45, 45, 90 triangle. And if the legs are both 10, then that means the hypotenuse has to be a leg with a radical 2. All right, so leg radical 2. All right, so let's find the value of each of these. All right, so here we have two legs that we don't know, but we know they're the same. And then the hypotenuse is 8. So the hypotenuse is always whatever the leg is times radical 2. So we can use this formula that says the hypotenuse is equal to u times radical 2. And we're going to solve it for u. All right, so I'll just come down here. And I'm going to divide by radical 2. All right, and now I just have to get rid of the radical off the bottom. All right, and so I'll do it right here. So we're going to multiply top and bottom by radical 2 to rationalize the denominator. So 8 radical 2 over, that's radical 4, which is 2. And then 8 over 2 can simplify to 4. So that means that each of these legs are 4 radical 2. All right, number 2, again, we have the hypotenuse, and we're looking for the two legs. So again, the hypotenuse is always u with a radical 2. Okay. All right, so now that we know that the hypotenuse is equal to u root 2, we can set 16 equal to u root 2, and then solve for u again. So we'll divide by root 2. And then we're going to have to rationalize the denominator again. So we'll multiply top and bottom by root 2. And then again, simplify this fraction. So that's going to be 8 root 2. All right, and so that's what x is. So each side is going to be 8 root 2. All right, then number 3, we have two sides that are the same, and we're looking for the hypotenuse now. And since we know that this, again, is a 45, 45, 90 triangle, we can see that each of these sides are the same, which we can call u. And then the hypotenuse is u with a radical 2. And since each of these sides are equal to 3, all we have to do is replace u with 3. All right, and then we get 3 radical 2. And so that's what x is, 3 radical 2. Right, and so let's keep going. So now we'll look at the 30, 60, 90 triangles. So we have a short leg, a long leg, and hypotenuse. So the short leg we call u. We call the long leg u radical 3, and the hypotenuse is 2 times u. So everything revolves off the short leg. So the short leg is going to be the side that's opposite the 30 degrees, and then the long leg will be opposite the 60, and the hypotenuse is always 2 times u, 2u. And so you can see how the ratio sides are broken down and labeled on the right triangle. And then on the other triangle with numbers, so we can see opposite the 30, okay, we call this u, which is 6, and opposite the 60 is the short side, which is 6, with a radical 3, and then the hypotenuse is 2 times whatever the short leg is. So 2 times 6 is 12. All right, so let's go ahead and find the value of each of these sides. All right, so it does help to label the sides, which one's u, which one's u root 3, and which one's 2u. Okay, so opposite the 30, we're saying that this is u. Opposite the 60, this is u radical 3. And then opposite the 90 is 2u. So we have to see which side do they give us. They give us one of the sides as a number. Well, this is the one they give us right here. So we know that u is equal to 10. Now, wherever u is in the other sides, we just replace it with 10. All right, so this is going to be 10 radical 3. And this will be 2 times 10, which is 20. So y is equal to 20, and x is equal to 10 radical 3. All right, number 2, opposite the 30. Okay, we're saying this is u. Opposite the 60 is u radical 3. And then opposite the 90 is 2u. So again, you got to find the side they give you. And so here, 16 is equal to 2u. And so we can solve for u by dividing by 2. So u is equal to 8. So wherever there's a u, we're going to replace it with 8. Okay, So that means that this side is 8, and this side is 8 with radical 3. So x is 8, and y is 8 radical 3. And then number 3, same thing. Opposite to 30, we're going to call this u. Opposite to 60 is u radical 3. And then opposite to 90 is 2u. All right, so here they give us that 3 is equal to u radical 3. And we'll solve for u by dividing by radical 3. All right, and then I'm going to rationalize the denominator here. So 3 radical 3 over 3, and simplify. So u is equal to radical 3. So wherever there's a u, we're going to replace with radical 3. All right, so this is radical 3, and this is 2 times radical 3. So y is 2 radical 3, and x is radical 3. All right, and that should do it. Yep. All right, so go ahead and try the Pythagorean theorem, and then the special right triangles, 45, 45, 90, and 30, 60, 90 triangles. Again, try to label the sides, and then simplify your radicals.